Welcome. So we're going to go through question 4b in this video. And again, I'm going to go through it very slowly. At the very end, I'll show you how to answer it quickly, but I want you to conceptually understand what's going on before that. So I want you to actually kind of visualize what's happening, but then at the end, I'll show you the quick way to answer it. Okay, it says, let me get a highlighter out. Decide if the given points, so those are 1, 1 and 2, 5, lie on the graph with the given rule. And our rule is y is equal to 3x minus 1. All right, so we're going to go about this the slow way. And what we're going to do is we're first going to graph. We're going to graph it. So to graph it, what we're first going to do is we'll create a table of values, and that will give us some points, which we can then put onto our Cartesian plane. And then we can use our ruler to join up those points to create a line. Now, one of the questions that I had today is, normally what we do in this case is we just go, all right, let's go 0, 1, 2, -1, -2. And we just use those points. And someone's like, well, why do I have to use these points? Like, how do I know that they would even go through these points? And there was a lot of confusion about this. So let's get rid of those points. I want you just to give me a random point. Give me a random point. Let's do the point 3. And what you're doing when you're looking at the point 3 there is you're saying, hey, when I have my rule, y equals 3x minus 1, when I let x equal to 3, what is my y equal to? So if I was to do that, I'm going to go y is equal to 3, and I'm going to sub 3 into my x spot, then subtract 1 from it, because that's what my rule tells me to do. 3 times 3 is 9 minus 1. So that means 9 minus 1 is 8. So that means I have the point 3, 8. So notice how I get a coordinate from this. This is the coordinate 3, 8. Remember, we read our table of values as giving us coordinates. So this is 3, 8. So that means that my line goes through the point 3, 8. This one right here. And now let's choose another point. Let's do -2. Why not? So I'm going to go, all right, when x is equal to -2, let me just make that a bit better. When x is equal to -2, I'm going to go, all right, what is my y equal to? So it's going to be 3. I'm going to put -2 in there, minus 1. So y is going to be equal to 3 times -2 is -6 minus 1. -6 minus 1 is going to be -7. So that means when I have -2, I get -7 out. So I can put a -7 here. I can come here, here's -2, here's -7. Now, I can actually draw my graph just based on these two lines. So let's do that. Here is this. I'm going to draw my graph. So I just remember my graph is just going to be, it's just going to connect these two lines together. Now, this sometimes can be a bit funny. Come on, you can do it. Give it a second. Come on. OneNote. You can do this. We did it before. Give it a second. Sometimes it's a bit temperamental. I'm going to zoom in. Let's see if this helps it out. I just need to go through that point exactly. Otherwise, if you've got a ruler, you don't have to go through this pain. I don't think it's going to cooperate with me. I tried it before. Normally, if you do this for a while, it does it smoothly. But I don't think it wants to do it smoothly for me. Oh, here we go. Here we go. Oh, I lost it. I'm going to give it 2 more seconds. Otherwise, I'm going to start this video again and hope it works the next time. I don't think it's going to work, everyone. There we go. We did it. Oh, I was so scared there for a second. I thought I was going to have to start the video again. All right. So obviously with a ruler, you don't have to go through that pain. You could just do it nice and quickly. You could just get your ruler, line it up, and then put it through. And I think that's pretty exact. So I've gone through both points exactly. This one looks a little bit off, doesn't it? But it's all right. If you go through it exactly, that's what you need to do. And then do you notice how by doing that now, everything else is actually just going to work perfectly now. So if I say, all right, when I let x equal to 0, what is my y value? Well, I could just look at my line now because I've drawn this perfectly. Do you see that when x is equal to 0, I get -1 out? So this will be -1. And we can check this out. We can go, all right, let me come over here. When x is equal to 0, that means I have y is equal to 3. I put a 0 in my x minus 1. What is 3 times 0? It's 0. What's 0 minus 1? It's minus 1. How cool is that? We found out by looking at our graph, and it's because we drew it perfectly that it went through. Now, actually, this should be over here, shouldn't it be 3, 8? Whoa. Because then I have 1, 2 here, and then negative 1. And then we can keep on just finding points. If I look at my graph, I should get 1, 2 out. So I should get 2 for here, and then I should get 2, 5 out, and I should get negative 1, negative 4 out. And sure enough, if I was to check these, they would all check out. So for instance, 2, 5, 3 times 2 is 6, minus 1 is 5. What about 1? 3 times 1 is 3, minus 1 is 2. What about negative 1? 3 times negative 1 minus 1, well, that's going to be negative 4 minus 1, which is negative. Oh, I can't. My apologies, everyone. You've got a maths teacher who... All right, 3 times negative 1 is negative 3. Then I'm minusing 1 from that, which is negative 4. There we go. So I get negative 4 out. 3 times negative 1 is negative 3. Minus 1 is negative 4. So you can see how we did that. Because I just had 2 points, then I ruled it up perfectly, and now I've got my nice little graph like that. How great is that? Now I need to check if these points lie on the graph. So let me just clean this up. All right, so it's saying when x equals 1, does y equal 1? Because it's saying 1, 1. So does this point 1, 1 lie on the graph? So let's come over here. Where is the point 1, 1? The point 1, 1 is there. Does that lie on the graph? No, it does not. It is not on the graph. It's over here. It's not touching the graph. But we want to know the quick way to do this, because that was kind of, we don't want to do it this way. We want to do it the quick way. You can see looking at our table of values that when I put 1 in, I get 2 out. So I know that this doesn't work because it's saying when I put 1 in, I get 1 out. The way that you check this is you say, all right, sub in x is equal to 1. And remember the rule, we're subbing it into the rule y equals 3x minus 1. Y is equal to 3. I put a 1 in there, minus 1 from it. Y is equal to 3 minus 1. Y is equal to 2. So that means when I put 1 in, I get 2 out. So this is not true. No, it's not on the line. We can see that graphically. And you can also prove it with the maths. By subbing x equals 1 in, we get 2 out. It's not on the line. What about 2, 5? Well, we can look at our table of values right here and say, look, there's 2, 5 right there. So it's obviously on the line. And sure enough, if I come here, 2, 5, there it is right there. It's on the line. But again, we want to be able to show this mathematically. So what this is saying is, hey, when you let x equal 2, does y equal 5? So let's sub in x is equal to 2. So that's going to be y is equal to 3, 2 minus 1. Y is equal to 3 times 2 is 6 minus 1. Y is equal to 5. So that means when I let x equal 2, y equals 5. And that's the point that they gave me. So yes. And do you see how that point here, 2, 5, it's on the graph? All right. Hopefully this makes sense. And again, you didn't have to draw it. Technically, none of that is needed. You could have just done this. So hopefully it's becoming a bit clearer. If it's not, don't stress. Again, this is a new concept, so I don't want you freaking out. Just come speak to me tomorrow and I can explain it a different way. But hopefully you've watched part A, you've watched part B now. Now try giving part C a go, but just do it this way. Don't feel you need to draw it out. You do not need to draw it out. All right. Hopefully this makes sense. If not, come speak to me tomorrow. All right. I'll see you in the next one.